Welcome to my talk. This is Craig Yu from George Mason University and Great Victory Legends. I direct the Design Computing and Extended Reality Lab at George Mason University. Our research focuses on personalized XR training, XR content creation, and XR remote assistance. I also run an XR company called Great Victory Legends, where we focus on AI-driven XR training middleware development. As XR game enthusiasts at heart, we also create our original XR game titles, which can be found on the Meta App Store and Steam. Supported by the National Science Foundation, the heart of my research lies on creating generative models for XR training scenario synthesis. Essentially, we formulate training scenario design as a multi-objective optimization problem. Given training goals, scene semantics, time constraints, trainee skills levels, etc., we apply optimization algorithms to generate XR training scenarios from a design solution space. To make this approach easy to apply, our company created the Recorder middleware, which captures a trainee's performance data during a XR training session, as well as the Optimizer middleware, which allows developers to easily run optimization for XR training scenario synthesis. The generated result refers to a personalized training scenario that satisfies all the training criteria, which can be readily deployed for XR training. Using this methodology, we generated a variety of XR training scenarios, including AR workflow training for a restaurant, multi-user VR fire evacuation training for a school environment. Here's an optimization running to distribute fires and other objects in the scene. The generated scene can be used for networked multi-user fire evacuation training across the globe. We also apply our optimization approach for VR wheelchair training scenario synthesis for rehabilitation. The user can safely practice wheelchair locomotion in the generated virtual environment. Another example is VR driving training. In this case, we generated virtual cities with road traffic events to help drivers improve their driving habits. The trainees' performance metrics, such as reaction time and eye gaze, were tracked during the VR training, which will be fed back to the optimizer to update the driving route, road conditions, and events to enable adaptive training. For example, if a trainee falls short of noticing jaywalkers, more jaywalkers will appear in the next training scene to reinforce his awareness and reaction. Here's another example of applying our approach for VR construction safety training synthesis. A user inspects a generated virtual construction site for potential dangers as part of her training. Our optimization approach also works for augmented reality. For example, we apply it for generating location-based outdoor AR storytelling experiences. Here, our optimizer is running to distribute story events to a real-world map. The generation refers to an AR story adapted and deployed to a real-world environment, which the user can experience wearing an AR headset. Similarly, our optimizer can adapt AR narratives to indoor environment based on this digital train. Here, the optimizer will take into account the scene semantics, such as the available furniture objects and the furniture layout, to determine where to put the virtual characters and how they will behave. Based on the results of more than 15 years of research, we created two pieces of Unity middleware that allow developers to create cutting-edge XR training experiences without reinventing the wheel. The first middleware is Optimizer, which allows developers to easily formulate XR training scenario synthesis as an optimization, and automatically generates an infinite amount of scenarios. Our efficient implementation of optimization algorithms allows scenario synthesis in seconds. It also comes with an intuitive UI for easy visualization of the optimization process and debugging. The second middleware is called Recorder, which allows seamless recording and replaying of XR sections for user performance evaluation and analysis, and for realizing ghosting effects. All data, including human poses, gaze, audio, particle effects, animations, dynamic objects, etc., can be recorded and replayed. Both middleware are designed for Unity and support all XR platforms like Quest, HoloLens, Vision Pro, etc. They can be integrated into your VR apps and run standalone on a VR headset. Here's a VR marksmanship training demo to show how our middleware work in practice. To generate a marksmanship training scene, the trainee first specifies the training difficulty levels as well as the layout and enemy parameters. Our optimizer then takes the trainee inputs and automatically generates an arena for VR marksmanship training. Here, different rooms are synthesized with different levels of complexities and training difficulties, with different numbers of rooms, obstacles, and wayfinding difficulties. The generated virtual reality training scene is fully playable. Here, a trainee walks through a synthesized VR training arena to rescue hostages. And a coach can record a tutorial for the trainee to follow through. Here, a coach shows how to take down an enemy, and the trainee follows his action in virtual reality. We also apply our middleware for generating biking paths for VR exogaming. In this case, we ensure that the generated biking game helps a user burn a target amount of calories. After the generation, a user bikes through the generated game to achieve his workout target. We are looking for commercial partners to bring such AI-driven bike gaming experience to the market. Want to take a break from training? Try out our VR arcade shooting game, Battle of Nowhere, which can be found on Steam and Meta App Store. We have successfully deployed our middleware to power VR training apps for our clients, including a Fortune 100 company. We are located at Fairfax, Virginia, which is right next to Washington, D.C. Let us know if you want to see a live demo and explore collaborations. Thank you.